Hi, I'm Mohammed, the founder of OptiDesign and a PhD researcher in the sustainability of the built environment. Let me ask a question. If we have this Lego plane, how many shapes we can build up here? Most probably less than the number of fingers. But in reality, there are hundreds, even thousands of shapes or possibilities that could be built up here. We have the same challenge in the construction design. We can think in more than few options, overlooking loads of better design alternatives for a given building area. So we need a generative algorithm that generates all design alternatives for this building area, which is like the Lego block or the Lego plate. The second problem we face in our industry is a lack of communication. That was proven through my experience in working in a design company when we were asked to foster the best design alternative for a given building area. We came up with 3 design alternatives representing to the client, showcasing the carbon emission of each alternative and the cost. The client chose the cheapest option, overlooking the carbon or the sustainability metrics, which showcasing the need of linking the feasibility of sustainability practices in the design decision making. Also showcasing the time wasted for such a process. We spent 14 hours for just coming up with 3 design alternatives, overlooking the optimum alternative if we generated all potential alternatives. Because of that, I came up with OptiDesign. I built a framework in my master thesis, and now I'm working with my partner, which is Ashraf. Ashraf is a digital engineering specialist, and I'm a sustainability specialist. We work together to build up the tool of OptiDesign. OptiDesign is an AI generative design assistant that generates all structural design alternatives for a given building area. The given building area would be done or designed by the architect, and all of the work would be conducted in a common data environment that we use in our industry, which is BIM, Building Information Modeling. Then OptiDesign would check all generated alternatives for structural safety, and then evaluate all of them based on 3 main criteria. The first one is the carbon emission, the second one is the energy consumption, and the third one is the life cycle cost. The life cycle cost include 2 parts. The first part is the material cost, and the second part is the expected repair cost. The meaning of expected repair cost is that if I have a timber building, I expect to have a maintenance for this building each year or each 2 years. But if I have a concrete building, I expect to have a maintenance each 10 years. So we account for this projected cost. All of these 3 metrics would be represented to the client in a financial score. How could that happen? We're gonna monetize the carbon emissions to the carbon cost by linking the carbon regulations with the emissions. Carbon regulation could be through carbon taxes or could be carbon credits. So instead of showcasing the carbon emission to the client, I showcase the carbon cost to the client. Instead of showcasing the energy consumption to the client, I showcase the energy cost. And at the end of the day, we'd have option A, option B, option C, until lots of options, having them ranked through a financial score. The last thing is the competitive advantage. Are we the first people to build something like that? No. We have the strong competitor to our tool, which is Structural Banda. But the problem in Structural Banda is that the Structural Banda is not integrated in the common data environment, which is BIM, which making it hard for the designer to handle complex geometries and make a lack of communication or coordination between the architect and the engineer. But we built up an agile methodology that showcasing the coordination or reinforce the coordination between the architects and the engineer. And the last part is the life cycle cost. We consider the projected repair cost, however, Structural Banda doesn't account for that. Tack för er.